Aha. Good, good, good. Okay. It looks like everything is working. That's always enjoyable. Let's make sure get the volume level sorted a little bit. I need to make sure I stay in focus as well. New camera and all that jazz. Hello, welcome. We are running. This is cool. This is exciting. So, yes, welcome. For everybody who is around and watching, we have a new fun setup going. It's very exciting. We've got new microphone, new computer, new camera, which will inevitably go out of focus at some point. There's no doubt about it. I do have a box up here for the chat, but I don't think it works. Oh my god, it works! Hey Axel, how's it going? There we go, cool. Okay, so we've got a box for the YouTube chat, so say hi, get interacting. It'll be cool to chat to you guys. It'll be really nice to get back in the swing of things. I want to just say before we get started, a big thank you to everyone for the support on the recent video that just went up, updating about the channel and everything. It has been a hectic kind of 6 months or so. But you know, now that university is off the table, and things are a little more chill in life, we're all settled in a house and all that jazz, it is gonna be a lot easier to get some things going and much more chill to kind of, you know, get these videos up and running. I've just increased the font size on the chat box because it was looking a bit small, so that's resetted any messages. Yeah, get chatting, say hi, and we're going to have some fun with some online code today. So I've got an idea that I've wanted to work on for like a long while, and Jaden, the other coder that's in the studio, will know about this. But it's basically like a kind of wave-based survival game. Imagine like a tower defense, but with the twist that all of the towers are crafted and you have to find resources and sort of put things together in a Minecraft kind of style, which sounds really weird and abstract just like off the top, but we'll kind of get into it. So I've always wanted to make this game online as well, or multiplayer in some way. Chances are we'll have local multiplayer in there, and it'll also be online network, but the focus is going to be online networking. And I've recently been learning how to use this cool new networking library called Fish Networking, which was made by a company called First Gear Games. They used to do a lot of videos about using Mirror and sort of getting around weird quirks with Mirror networking. And eventually the guy who runs it all just made a new networking solution called Fish Networking, which is really cool. It's got loads of cool features built in. It works very similarly to Mirror, but it's got things like client-side prediction and server reconciliation built in for free. It's one of the only networking solutions that gives you that for free, so that's really cool. And it's just really nice to work with. So we're going to spend today in the stream doing that, setting up the kind of basics of integrating that package with Steam, creating a lobby, and yeah, just kind of setting up the foundations for getting people able to join, and it should be good. Yeah. So I'm trying to think about how best I want to do this, because one thing I should say ahead as well, the new computer, it's a Mac, of course, because I'm an Apple boy. It's one of the new M1 MacBook Pros. Cost me a lot of money, but obviously, you know, Apple being Apple, it's all USB-C stuff, so I don't have my Stream Deck plugged in because I've got the camera plugged in, and I've got my audio gear plugged in, so I can't switch between things easily, but that's fine. I've got transitions, so we can do this pretty easy. Let's not waste any more time, shall we? It's been 5 minutes. Let's jump on into Unity and have a look around what we've got already. So, basic setup of the project. We're looking at 2D kind of thing, keeping it simple. Top-down controls, I'm thinking. I've got a few packages pre-installed and a few scripts that I've made before when I'm experimenting with the system in there as well. By the way, if anything is too small on screen, specifically with like code and stuff, because we're running a new overlay and things, just send a message, or if there's any issues with the audio or anything, this is all, you know, setup is new. Let me know if there's any teething issues and we'll get them ironed out. So, packages that we've got, the important ones, of course, Fish networking. That is, as I say, the library that we're going to be using for all of our online networking code, and is, yeah, very, very important to being able to do any of the online stuff. For Steam integration, we are using Hidden Steamworks, which is a wrapper for the steamworks.net. Ooh, mic audio went a bit wonky after I switched scenes. I think I can fix that. Hold on. The problem will be that I've got probably, have I got like a different thingy in here? Oh, I shouldn't do. Hold on. Let's have a look. Look at them smooth transitions. Oh, I've definitely made the font size on the chat way too big as well. Look at that. That's massive. That's interesting that this doesn't show up on this screen either, though. I've probably got some different properties set up on this one. Let's get rid of that. Font settings. Let's bring that down to maybe like 25. Or maybe it's just my cable's a bit knocked out. If I come back here, that's still the same. Let's have a look. Oh, that looks like it's alright now, I think. If I've got to make sure not to like shout in the microphone, because it's... Yeah. That's good, that's good. Okay, don't shout in the microphone, Cuba. Don't shout in the microphone. Put that down to there. And we are back. Okay. So, yeah. Hidden Steamworks is a wrapper for steamworks.net, which is like the C# implementation of the Steamworks API. That gives us access to things like lobbies, usernames, Steam inventory, achievements, etc., etc. And then there's one final package that goes with that, which is Fishy Steamworks, and that is the Steam transport for Fish networking. Similarly, if you've ever used something like Miro, or you know anything about Miro networking, or any other networking library for that matter, there's you have what's called transport, which is basically like the back-end parser for the high-level API that handles things like socket connections, actually transferring packets and things like that. Lots of stuff that I vaguely know about because of what I did do at university, but don't really understand very much because networking is like my worst subject. But that all gets handled by the transport and the network manager. So basically the Fishy Steamworks transport layer just handles all of the Steam networking side of things using peer-to-peer connection. Other than that, we've got a couple of scripts which, as I say, I pre-wrote some scripts, one of which is this UI view manager. If we take a look at this over here real quick. This is actually a system designed by, what's the channel called? It's like Wintermute or Winterbolt Games, I want to say. But he's a really good YouTuber, has done a few live streams about fish networking, knows what he's talking about, and he has this really nice system for managing UI in Unity, which I absolutely love. It basically uses like a pseudo singleton instance for all of your views, which are basically the UI screens that you have. You set a default view as well, and it basically, you can just pass in the type code-wise, pass in like a class type that inherits from this class abstract view, which we'll take a look at as well. You're gonna open, there we go. Really simple class. You just have a boolean for if the view has been initialized, a method to initialize the view, and then a method for showing and hiding the view, which at the moment is just setting it active or setting it not active. In future, this will probably have things like sound effects and animations in there. But yeah, the UI view manager is, you just pass in the inherited type and it will find that type in its list and show it and hide everything else, which is very handy dandy. The other thing that we've got is this class called Steam Lobby, which is basically what's there for handling brain function, handling the setting up of a lobby on Steam side. Oh, my lighting has just gotten very bright courtesy of the sun coming out outside my window. So, to explain how this class works, basically something that people always think, or certainly I used to always think about wrong, and I think a lot of people who are just getting into networking code think about wrong as well, is that a lobby is a networked thing, and it's not. All a lobby is just like it's basically a data structure for holding information about people in a group. There's no networking code going on there. There's nothing interesting going on that actually does the connectivity of your game, and a lobby isn't a networked state in the sense of, you know, how something like Unity's lobby system that just came out with the gaming services works, or how Steam's lobby service works, or anything like that. It is just a way of grouping people. So what the Steam lobby class actually does is it handles that API stuff on Steam side, where we create the group of people, say to Steam, here's all the people we want in this group, and this is where you can categorize them. And then it also makes the connection on the fishnet side of things by starting a host and starting a client, or by starting a client if someone's connecting to the host. And the way that you connect to a host in Steam is by passing in the username as the connection address or the host address, rather than passing in something like an IP address, which is specifically why I'm using Steam for this game, because a lot of people still don't understand how to do port forwarding, or still have trouble with port forwarding, even after Minecraft having been around for as long as it has been. So Steam is like, having those lobby systems makes it a lot easier, and the same goes for Unity's lobby system as well. The way that Steam works with all of its things is you have these things called callbacks for when certain events are fired off. We are using 3 of them in this case. We have one for when the lobby is created, one for when someone requests to join a lobby, and one for when someone actually joins the lobby. So all of these will basically fire off their respective methods, which we'll look at in a moment, which are on lobby created, on game lobby join requested, and on lobby entered. So whenever someone does one of these actions, the respective method will be fired off. And we have to do a check beforehand to see if Steam is actually running on the machine that we're trying to do this on, because if it isn't, we're going to get a bunch of errors. So we just return out of the awake method if Steam Manager is not initialized. Deregistering the callbacks in the onDestroy method, because otherwise we'll end up with some weird issues going on where if you move to a different scene, then come back to the main menu and try to connect again, it will try and connect you twice because it fires the event twice. We'll just keep adding in those callbacks, so you need to make sure to unregister them. And then we have a method called host lobby, which will fire off from the UI basically, and this simply goes into the Steam API, and we call create lobby with friends type being, the connection type being friends only, and allowing up to 6 people in the lobby. Cool. So after that we have the methods that I was talking about. or the callbacks that I was talking about, we have on lobby created, so this will be fired when the lobby is created, as you can probably imagine. This first of all does a check to say if the lobby wasn't created okay, we need to say that the lobby wasn't created okay, and eventually we'll make a UI pop-up to spit that out on screen and be like, there were problems. But for now we're just logging out a warning and then returning out the method. If the lobby was created okay, that's fantastic. We grab a reference to the lobby ID by grabbing a new CSteam ID from the callback information, because this lobby created callback holds all of the information about the lobby that we've just made. We then make use of the very nifty instance finder in Fish networking, which basically gives you access to all of the singleton instances for any of the networking components we need. Things like the server manager, client manager, time management, all of that important stuff. We can grab it by doing instance finder dot and then the thing we want. So here we're getting the server manager and we're starting a connection because we want to run as the host. And I'll explain why we're only starting the server in just a moment, because it's a little bit quirky compared to how Mirror works, in the sense that Fish doesn't have a start host thing. You are just the host if you're running a server and a client. So typically you would start the server connection and then start the client connection. And once both of those are running, you'd be considered the host. But because of the speed that things execute at, we don't want to start both things here, because we actually end up with the server connection starting before this lobby entered callback runs, and so we try to start the client twice. And we'll get onto the joining the client afterwards. But for now, when we create the lobby, just know we start the connection for the server, and then we set some data on the lobby for what the host address is, which, as I was saying earlier, when connecting on Steam, you connect to the user's username, the lobby host's username. So we set the host address to whatever our username is in Steam. Or whatever our Steam ID is, sorry, not our username. Then we're grabbing the username further down, setting the name of the lobby to be whatever our username is lobby. So for me, that would be Cubsyman234's lobby. And then I'm just doing a debug log to say that we've hosted the lobby successfully. Nothing too crazy, it's actually pretty simple. It's just like getting into the space of understanding how all the Steam API works and that. When we request to join a lobby, we just go straight ahead and call Steam matchmaking.joinLobby, passing in the lobby ID of the callback. This is fired when you go into Steam and you right-click on your friend's name and hit join lobby, or if someone sent you an invite and you hit the accept invite button, that fires this on-game lobby join requested callback. And then calling join lobby fires off the lobby enter callback. So at this point, when you're entering the lobby, we do lobby ID equals whatever the callback's lobby ID is, just so we can cache that locally. We also grab the host address by going into that lobby data that we set when we were hosting the lobby in the first place. Pull that back out by the host address key. We then start our client connection with that host address passed in. So if you remember from earlier, that host address is the Steam ID of the user that's hosting the lobby, and then we do a debug to say that we've connected. So the reason that we have these two separate is because when you create a lobby in Steam, it actually joins you to that lobby automatically. So when we create the lobby, we can start our server connection, do all the hosting, set the lobby up, and then straight away, as soon as all of this is done, it's going to call this on lobby entered method as well, because it will fire the lobby enter callback. Which is why we also get the weird race condition, I'll say, for want of a better term, because it's once the server manager is it takes more than a couple of frames to start the client. So if we went up here, for example, and did an instance finder client manager.start connection like that, on our end, or on the on lobby created, it'll get to this line, and then we'll say, client starting, but not started, just starting, And then by the time we get down here, client is still starting. And you know, I'm going to zoom in my text a bit just so it's a bit more clear on my screen. It's looking a little small. Yeah, so the client is still starting when we get here, but when we have gotten to here, this method's already fired off. So here, client from host is still starting. And I think this is not necessarily a guaranteed issue. It might just be like a specific machine thing or a network speed thing, because my network is slow. I'm one of the unfortunate people who still lives in an area that doesn't have super fast broadband, so we still have a relatively slow connection. But that's why we don't start the client up here. We just wait until it calls the onLobby entered callback and start it down here as well. Cool, so that's all of our preliminary code that we've got set up. So what I want to do in the stream today, and I've been waffling for a while, so I've got like an hour and a half left before we're going to end the stream. The goal for today is to set up the basic UI views for a lobby and the main menu, get players joining, connecting to each other, and being able to press the start game button and have little squares that can move around the screen. All of which, with the power of Steam networking, not Steam networking, Fish networking, I think we can fit into a couple of hours. So if you're ready to learn along with me, let's get started. First of all, we want to create a empty game object in our main menu scene, which I'm going to call Network Manager. And as you would guess, this will be our Network Manager. So I'm going to add a Network Manager component. Oh, look at that. Yeah, that's fine. So the Network Manager is basically like the brain of Fish networking. This will handle everything we need it to, and a really cool thing about it as well is that it adds all of the components it needs that we haven't overridden automatically. So if we only need to customize things like scene management, for example, it will just add everything else. We don't need to worry about it. Something we do need to do is set this list of spawnable prefabs, so I'm just going to use the default prefab object. That was what the error that got thrown before was about. And I think that's everything we need to do. I'm also going to, do I want to change this to destroy oldest? I don't think I do. For now I'm going to leave everything else as is, that's fine. So I want to create some UI objects. So let's go ahead and do that. We are going to create a button. Where are you? There you are. And this will be my post game button. We're obviously not going to have a join game button. I need to make sure that I import all of the TextMesh Pro Essentials as well. It's one of my bugbears about TextMesh is that I have to import the TextMesh Pro Essentials every time. Like, you'd expect that it just would import the Essentials with the package, but no, it doesn't. Cool, so let's go ahead and first of all put a... wait, has it done it automatically? Am I not using the new input system? I want to be using the new input system. I'm not. Well, let's do that straight away. I'm kind of thinking I want to change the music as well. I'm not sure if I'm vibing with Zelda music right now. Grab my browser back. We are gonna do Minecraft music in the rain because it's chill vibes. I'm gonna just turn it down a bit as well. Yeah, there we go. This is like one of my favorite programming backings. It's great. Cool. All right, so let's replace that with an input module. Our canvas reference size, we want it to be constant. Wait, no, scale screen size. Yes, there we go, scale screen size. And we want it to match the height. Gonna make it 1920 by 1080. And I'm gonna go ahead and just make a new button because there we go. Have it in the center. This is the host game button. I think we'll make it a little bit bigger as well because he feels a little small. And then let's change our text to say host game. Very cool, very nice. I might just up the font size to 32 as well, so it's nice and clear on screen. I'm going to change the background color too because I really hate the Unity blue. Go with the gray. And let's move all of this stuff down so we can see our game view a bit more clearly. Cool. So this is where we're going to start bringing in views. So I'm going to create an empty object, and this is going to be my main menu view. And this is using that view system that I was talking about before. Trying to find a place to put my phone so I can see what's going on the screen. Also, do remember to say hi. I love chatting with you guys, so if you've got any input or anything you want to talk about, do say. So the main menu view, we need to create a script for this, unless I've already got it. Conveniently, I've already got it. It's another one that I made earlier. So we'll also need a quit button, but basically the way this script works, it inherits from our abstract view class that I was talking about earlier. We have a reference to our Steam lobby as well, and we have a host button and a quit button. When we initialize the view, we find our Steam lobby and get that reference for that. We then set some callbacks on our buttons. The host button is going to fire off Steam lobby.hostLobby, which, as discussed before, is this method up here, which runs the create lobby method on the Steam API. And then the quit game button just runs application.quit. Finally, we run base.initialize, which, if we remember, just sets initialize to true. And then the rest is all pretty default. As per on destroy, we want to remove all our listeners for buttons so we don't double stuff up. And then we're not doing any override stuff in here, so I can actually just delete this method. So with all that, we can move our host game button as a child of our main menu. Before I do that, I'm just going to make sure that I have this scale. And let's also duplicate the host game button. This is going to be our quit game button. Whoops. We will move this down a little bit. There we go, maybe minus 75. And we'll change the text on this to quit game. Yeah, cool. So we'll also create a empty game object called view manager. This is going to have our UI view manager class on it. And we need to set this up with a couple of things. First of all, I want to make sure that I check the auto init. This just means that it'll initialize automatically. And the reason that we have this check is because when networking, you don't want to network any UI. It's bad practice. You want clients to manage their own UI and kind of pass any networked information through to their UI. That goes for lobbies, in-game UI, all of that jazz. We shouldn't be networking our UI code. So on the lobby side of things, I don't want to initialize the UI automatically. I want to have the player initialize it after it's joined so that we can make sure we have all of the data we need, like other members in the lobby, etc., etc., before we set up our lobby UI. So in the case of the menu, we want it to just initialize straight away. Otherwise, or in some other cases, we don't. So our main menu, I also want to add on our main menu view. We'll drag in our host button and quit game button references. and we will pop this bad boy into our views list and also set him as our default view. So now when we press play, we have an error. Fantastic. Value does not fall within the expected range. What do you mean value does not fall within the expected range? UI View Manager 33. Yeah, view somewhere initialize. What does it mean? That's really weird. Let me press the button and see if it does anything. Pressing the button didn't do anything. That's a weird error. Value does not fall within the expected range. I've literally never seen this error before with adding listeners to buttons. Yeah, we've got the host button. That's all good. Button is all set up as it should be. Only throws it for our host button as well. If I comment this out, I'm going to do some tests real quick to see if it's specifically the method that's giving me the issues or if it's the adding of the listener. Whoa. Okay, so it's the host, this Steam lobby.host that is giving me the issues. So what I might do is just, oh no, yeah, I'm an idiot. I haven't actually put our Steam lobby in anywhere. Okay, so I forgot two things with Steam, which are relatively important that we need to make sure we do. First things first, obviously we need to have our Steam lobby. So I'm going to stick my Steam lobby class onto here on the network manager. Second thing, you need some way of interfacing with Steam. As you know, we're using the Steam system. There has to be something there that's gonna talk to Steam, and the way that we do that is with what's called the Steam Manager. You have a couple of options here. You can either make one yourself, but that's effort and kind of unnecessary unless you're doing crazy stuff. So lucky for us, we get a default Steam Manager component from Fishnet. So we're going to go ahead and add that straight onto a separate object. Reason being, if I try and stick it on the network manager, it'll actually just delete itself and make a new one, which will delete all of our network manager stuff as well, and we will have problems. So if I press play now, we should see that we don't have any more errors. Yep, cool, no errors. If we press host game, there we go. We get some fun little logout stuff going here for lobbies being started and all that jazz. We need to set up our transport for Steam as well. Final thing I'll forget to do, I swear. So on our network manager again, let's add a transport manager. And we will also add a fishy Steamworks, which is, as I was saying before, the transport. So let's talk about what the settings here are. The most important one and the main one that we really need to worry about is the Steam app ID. This refers to the, as you'd probably guess, the app ID in Steamworks, which if you're making a game for Steam, you'll be able to get. There is this default Steam ID 480, which refers to a test game called Space Wars, which is like the easiest thing to use to test your networking code before you've maybe paid the fee, or if you're just testing the game out, if you don't want to have to faff around with keys and stuff. That lets you test it with your friends and things over Steam before anything's set in stone. And then the final thing we want to do is check this peer-to-peer checkbox, and that basically tells it that we're going to be using the peer-to-peer Steam sockets networking. That's everything we need in there. We will drag and drop this into our transport manager. And finally, if we press play and hit the host game button, we can now see in our console over here, we have things logging out that local server is starting for Fishy Steamworks, local server started, hosted lobby successfully, local client is starting, connected to lobby successfully, local client is started, remote connection started for this thing. So we have connected now successfully to our lobby through Steam, which is really cool. Very good, very nice. So we can get into some of the fun stuff now. We can start messing around with actually building up our lobby. I've got a bit of echo going on my microphone, don't I? Oh, I know why that is. I know why that is. It's this. There we go. Yeah, there we go. Much better. Okay. That should be the last of the teething issues now, I hope. Hopefully the camera doesn't go out of focus. I need to get like a blackout blind for this room as well, so I can stop the sun from messing up my lighting. Damn. Okay, so I'm trying to think what order I want to do this in. I think the first thing that I want to do maybe is if we create a player component. Because basically when you, with like network APIs, and this seems to be pretty typical of most of them, when you move to an online state, it can be favorable to have a player prefab or some instance that you can spawn in to represent that player's connection as like a primary object. Another thing that's important to differentiate when doing network code, which again is something that only just clicked in my head relatively recently, is that the object is not the client. The client is the computer with all the objects on it, or the instance of the game. That is the client. I think a lot of people, when they dive into these like online tutorials, and you know, I won't speak for everyone, but certainly something that I did, diving into mirror tutorials and stuff, I'm like, so the player object is the client then, right? But no, that's not how it works. You can have client and server code on the player object on a specific machine. They'll just run in different places, and that's takes a minute to get your head around. So I want to create an object that will represent our player generally, as a, you know, like a holder for all of the information about our player. So things like our Steam ID, username, any cosmetic settings, things like that. So let's go ahead and create I'm going to make a new folder underneath my networking folder called player code, or player systems. Let's do that. And we will make a new C# script called player network object. Pop this open in Visual Studio. Oh man, I'm not used to things just opening straight away. So this is going to be our first networks object. In Fish networking, these are very simply called network object. So we will inherit from that class. And that will give us access to a whole bunch of stuff that we can use. What do you mean? Wait. Network behavior, sorry. Behavior, not network object. Lots of network X, Y, and Zs. So. Oh, the apple juice is sour. Okay. So, in my player, I want to keep track of the username and the Steam ID, basically the main thing. So, and we want to make sure that these are synchronized over the network as well. Because basically, the way this works, and I wish I had my like proper art software installed on my new computer so I could draw a diagram for this, but if we imagine we have two instances of the game, you'll have you've got two computers, both of which are connected to the server. They're connected to the online network. Both of them are going to have two instances of our player network object on there. because they're networked objects. They're going to appear on both things. They're going to be on the server and on the clients. And we want to be able to keep track on those specific objects, the specific instances of this player network object class. We want to know which one has which data. And so most high-level APIs for networking provide us with some system for synchronizing these variables over the network. And in fish networking, those are called sync vars. So we're going to make a sync var, import our fishnet.object.synchronizing, which is going to be a public ulong. And this is going to be our Steam, let's call it player Steam ID. So this is going to be the Steam ID of this this player objects Steam, player objects Steam. I'm also going to have a sync var, which will be a public string player username. I won't comment that because that's pretty self-explanatory. I mean, to be fair, so is player Steam ID. So that's let's get rid of that comment. So this is all very well and good. And then sync vars basically are they're variables that can only be set on the server and will then synchronize to clients. So there's two ways we can set this. We can either set them directly from the server, or we can use what's called an RPC to send a message from a client to the server and change the value. So we are going to sort of do it in two ways. We're going to start off with on the server side. Let's just clear out some of these things here. There's some methods in fish networking that we can use for running stuff at certain points, certain callbacks that happen when objects are created. So one of the methods that we get is on start server. So this gets called on the server when initializing this object. So we're going to use this for setting our basic information. When we start the server, we want to, whenever we override a method of network behavior, we always want to run the base first. So let's add a comment here saying always run the base first, exclamation mark. That's really important because it does like a whole load of stuff in the background, which if we try and do things before that, or if things get thrown out of order, it can cause some really weird issues that are quite hard to debug. And yeah, we don't want to be we don't want to be worrying about that. So we're going to let it do its base behavior, and then we're going to do what we want it to do. So quite simply, we're just going to set our player Steam ID. We will say player Steam ID equals, and we're going to do Steam matchmaking dot get lobby data by index. Is that what I want to do? No, it's not what I want to do. What do I want to do? I want to get the Steam ID of the player that's just joined the lobby. Tell you what, let's make a game manager real quick. So I'm going to use the game manager to keep track of what players have joined and left. Oh well, what players are in the game, and also to run our game loop. Our game manager will also be a network behavior. Oh wait, have I already made a game manager script? I have. Fantastic. Let's pop that open, shall we? Don't save there. So like I say, network behavior on here. And like I say, I want to have a list of what players are in the game. So the way we can do this is Fishnet ships with a data type called sync list, which is, as you would probably guess, a synchronized list. And we can synchronize this across the network using the sync object attribute, because it's a custom data type, and this is, you can't read it here because it's too small on the screen, but it synchronizes collections or objects from the server to clients, similarly to our sync variable, which synchronizes a variable from the server to clients. So let's have that public sync list, can't type, sync list of type player, and this is going to be, oh sorry, player network object. This is going to be our players with a capital P because it's public, and we'll say equal to new because we're using C#, like, is it 9? C# 9 or C# 7 or something, which lets us just say new and it will know what we're talking about in the background, so it makes life nice and easy. I'm also going to add an update method, public void update, which we're going to use just for debugging purposes. So I basically want to print out how many players there are in the list. And we'll also eventually track how many players have readied up in the lobby. But first of all, I'm just going to put a if statement to say, oh no, I'm not going to put an if statement. Let's just do the debug. We're going to debug.log. And we'll use an interpolated string, players in game, and then we will do players dot count, like so. So when we start the server, let's just go ahead and do let's add ourselves to that list. We want a static instance here, so a public static game manager instance, have get private set, we'll also public void awake. These should be private, not public, and I'm gonna change them because I'm a bit picky like that. How's everyone following along so far? I'm scattering around a little bit, but hopefully y'all are keeping track. There we go. We'll set the instance to this. So we'll say game manager dot instance dot players dot add, and we're gonna add this. There we go. Nice and simple. Waterflow. Hello. How's it going? Hope you're doing good. I really want to figure out why the YouTube chat isn't showing up on my my chat box here. I think I just need to source fresh done, and hopefully that'll actually show some things up. Let's make it a little bit more scaled into the box size as well, because it's a weird one. It works in the waiting scene. If I switch back to my beautiful face, look at that. There's stuff coming up. It's just not coming up on the one in the other screen. So we'll see what's happening. You're a complete noob with networking, so you could say absolute nonsense and we wouldn't be able to tell. Nice. That's well, that's good. That's good for my side. At least it means I can mess up and it's not terrible. So I've just been prompted to say that this needs to be read-only, which, yes, it does. We want this to be read-only anyway, because we don't want to be able to create a new instance. And it's always another confusing thing that I've had with making lists read-only, because you're like, it's read-only, can I not edit it? You can add and remove stuff from the list. You just can't edit the instance of the list. Like, you can't change to a new list. You couldn't say at any point, for example, if I did it down here, I wouldn't be able to say players equals new, because it's read-only, so we can't assign to it. But we can edit the list itself. We can add things and remove things. So let's also have a public override on stop server. So this is called on the server when a client disconnects. As always, always run the base first. And then we will do game manager .instance .remove players .remove this. Cool. So now that we've done that, we've got a game manager which can keep track of our players. It's going to tell us how many people are in the game. We've also got a player network object which can join and leave as it pleases. Let's go ahead and test that everything works. So we need to set up our things in Unity. We're going to basically create a prefab for our player because we want to instantiate it when the user goes online. So I'm going to make a new folder, prefabs. And we're going to stick our player in there. I'll create an empty object. This is going to be our player network object. And I realize I'm moving quite fast here. If anyone wants more information or you want me to slow down a bit, please do just say in the chat. I will pull back. So on this player network object, I'm going to give it the tag of player. And we're going to drop on the player network object script. We can see that this is automatically added in a network object script as well. I'm just going to move that up to the top. And this is a requirement of any network behavior. It's basically the thing that allows us to communicate with fishnet. So let us make a prefab of that. We can delete it from our scene. I'm also going to go ahead and create a game manager, which we'll pop our game manager script onto. Let's move the network object up to the top. And we're actually going to change this slightly in a moment. And I'll explain why when we get there. But for now, let's just have it as an object in the scene. Which I'll also make a prefab for, both for later reasons and because, you know, it's nice having stuff that you'll reuse as prefabs, so that we can make changes in the scene and it'll propagate to all other instances. Cool, so we want to have a way to be able to spawn our player network object when we join the game, and Fish provides us a really nice way of doing this with the player spawner. So we'll add that onto our network manager object. It's really cool. It just takes a prefab for the player prefab that we want to spawn. We'll uncheck this add to default scene box. And it also, you can add a list of spawn positions to spawn stuff at. We're not going to bother with that because, like we said, this object is just a representation of our player's connection, holding key information about the player in there and all that stuff as well. So if we press play and hit our button to host the game, there we go. We can see that we have spawned in a player network object, and we also now are getting a log out saying players in game is one, which I respect maybe is not visible on the screen, but we have in fact got a player connected to the game. Awesome. So let's take this a step further. Let's actually make a different scene for our lobby. So I'm actually just going to go ahead and duplicate our sample scene and rename it to lobby scene. You'll notice I've also deleted the game manager from our main menu, and that's because we're going to move it over to the lobby. Let's rename our sample scene to main menu, not main menu, main menu. And we can change up our view manager. So this now, we're going to rename this to lobby view, and we're going to get rid of our quick game button because we don't want that in there. We're going to remove the main menu view component from our lobby view object, and I'm going to change this host game button to leave lobby. I think that's how I want to do it. I've kind of got. I'm in two minds about how I want to do lobby stuff. We can either have it so that the player. Actually, you know what? Yeah, let's get a vote in chat. We got a few people watching. Send a message in chat to let me know if we should spawn people. If people should have physical objects in the lobby that can run around, like in Among Us, for example, or if we should have a basic old-fashioned style lobby that's got like a list of player objects representing each of the members. I'd be interested to know, because we can do both approaches. Surprisingly, it's actually easier to do the first option. Nice, the first option. Physical objects, more work equals more better. Nice. I mean, as I was saying, it's actually easier to do the first option, I've found. So I am perfectly happy to do that. Cool. You can't take it back now. So we're going to have physical objects running around the lobby. In which case, let's think about how we want our lobby view to be designed. So we're having a top-down game, which is great. Let's have a... Yeah, I'm getting ahead of myself. We'll worry about creating that guy in a minute. For the time being, let's just save this here. I'm going to create a UI text that says this is going to be just a lobby name. Lobby name goes here. Let's make it center aligned. We will, yeah, scale that over the entire screen, even though this is not what we're going to do in the final thing. I just want to do this for demonstration purposes. We're going to remove the network manager and the Steam manager because these are both global objects. They'll get moved over when we move scene. And let's go ahead and create a new folder under the views folder, and I'm going to call this lobby UI, and we'll make a new C# script, which will be our lobby view. Pop this open. So, as I mentioned before, we don't network UI code. That's not something you do. It's bad practice. So this is going to remain as a mono behavior, and we will, instead of doing any networking stuff in here, we'll use like a combination of broadcasts and just setting data in networked objects that can be referenced by the lobby to show what information we need to show. So I'm going to have a serialized field, which will be a private text mesh pro UGUI. Let's import that text mesh pro package, and we are going to call this lobby name display. I'm going to override the initialize method. Oh, I need to make sure I'm inheriting from our abstract view class, sorry. Override the initialize method, and what I will do here is simply say lobby name display equals steam lobby dot, wait, no. I'm going to get a reference to... no, yeah, I'm going to say lobby name display dot text equals Steam matchmaking dot, let's make sure we're importing Steamworks, get lobby data. And as I said, this is not networking stuff, this is just Steam API stuff. We're still not doing any netcode in here. So we'll do Steam matchmaking.get lobby data. We'll pass in our Steam lobby ID, which is a static parameter. Or we need to pass that as a Steam ID type, not just as a ulong. And we want to get the name of the lobby. Very simple. And I'm also gonna do something fun as well, just to kind of make life a little bit easier. Let's have a serialized field private text mesh pro UGUI again, which is going to be a lobby member count. And in our update method, we will just do, if we're not initialized, we'll return, because we don't. Well, I'm also going to do this in the late update actually, to make sure that all the information is actually passed over. But yeah, if we're not initialized, or if we're not initialized, we'll back out. If we are, let's set our lobby member count.text equal to game manager dot instance dot players dot count. Or actually no, let's do this as a string. Interpolate string. Players in game. There we go. Cool beans, cool beans. So let us sort out our UI scaling, shall we? Let's make this a more appropriate size. Let's duplicate it. This will be our player count. And I'm going to move it down a bit to like there. And let's say player count. And I mean, this is going to be, it's going to be interesting to test, because something that I haven't mentioned so far, if we're making a game for Steam to run, you know, Steam networking online, you can't actually test Steam games online on the same computer like you would with a normal one. So we, when we're building, if we wanted to test this across multiple computers, I'd have to build the game, send it to my work laptop or my other laptop or my girlfriend's laptop or something, run Steam on that computer, add it to Steam, and then run it through there and do the connections like that, which is a faff. So in this stream specifically, we're not going to worry about that, because the other way I could do it is by uploading builds to Steamworks, but NDAs and all that jazz mean I can't share any Steamworks stuff on stream. So if I get everything set up for next time, we'll do uploads and actually testing things over the network on stream in the next stream, which will be some point early next week, probably Tuesday. Until then, we're just going to test with one player. So let's go ahead and add our lobby view component onto the lobby view. We're going to put the lobby name in there and the player count in there. On our view manager, we are going to set the default view to our lobby component. We will also add the lobby view to our lobby list. We're not going to initialize automatically, because what we want to do now is have it that once the player has finished doing all of its stuff on the client side, we'll initialize our UI on the client from there. So if we head back to our player network object, we have another override method called onStartClient. As usual, always run the base first, because we want that to do all of its stuff. And this is actually where we're going to do things like grabbing our Steam ID and our username and things like that. So we won't worry about doing those bits yet. For now, I just want to go to our UI view manager and initialize it. Instance, there we go, .initialize. And then I want to do my UI view manager .show, instance .show, and we're going to pass in lobby view. Like so. So now when the client starts, so as I say, this is on the client side, this runs on the client after the object is initialized. when our client starts, we are going to initialize the UI on that client and show the lobby. Very cool, very nice. So the final thing we need to do is set up a way of switching scenes when we come online. And that's really easy. Again, we get a component for it called default scene. So we'll add that onto our network manager, and this is really cool. We just get to drag and drop the scenes that we want for offline, which will be our main menu, and online, which will be our lobby. And then we'll set the replace scenes to all, because we want to replace all of the available scenes when we switch. So if we press play now and press the host game button, oh, I've busted something. Lobby scene could not be loaded because, oh yeah. We need to make sure we go into our build settings and actually add the lobby scene to our thing, because under the hood, Fishnet's Steam management, Fishnet's scene management, not Steam management. Fishnet's scene management uses the Unity scene manager system. So if we haven't got the scene in the build, then it won't be able to load the scene. Let's try that again. Rookie mistake on my part. Host the game. There we go. So we can see we have Cubsyman234's lobby and players in game is 1, which is fantastic. This is great. I would really love to be able to test adding another member so we can see that tick up in real time. Because what will happen, because we've got this running on update in our lobby view, it's still running on the client side. There's no network code in this lobby, but because our game manager has a networked object here, on the server, whenever a player joins, we add that player to this list on the server, and as I explained earlier, because it's a sync var, or a synced object, when it gets updated on the server, it will propagate that information to all of the clients as well. So we'll also be adding that player object to the list on all of the clients, and therefore in our late update, when we set this to the count of GameManager.instance.players, it will show 2, because we have 2 people in the lobby. Awesome stuff. So now that we've got all that out of the way, I guess we want to start looking at actually setting some of these values and things in here. Oh, and I kind of don't want to because I vaguely can't remember how to do it. So I mean, we have an option here for getting the username, but we don't really just want to get our username like that. We probably want to do steamuser.getID, yeah, do all that stuff. So on our player network object, let's introduce RPCs. So as I mentioned before, we can only set sync vars on the server. We can't set them on a client. So if we want to set anything, if we want to set any sync vars from a client, we have to send a message from the client to the server to set this information. And the way that you do that is with something called an RPC, or a remote procedure call. Fish networking, again, very helpful, provides us with this attribute called server RPC. If you stick this on top of a method, so we'll have a public void server set Steam ID, for example, and this is going to take a ulong Steam ID. So now we can call this method on a client or from a client, and it will run this code on the server. The server RPC attribute comes with a couple of parameters as well. There's one called required ownership, which objects that exist on the network will be owned by a specific client or a specific connection. They might be owned by the server, they might be owned by one client, another client, whatever. By default, calling an RPC from a client or a client object requires you to have ownership of that client object. So we wouldn't be able to call, for example, server set Steam ID from a client that doesn't own this instance of the player object. and therefore it wouldn't run. If we wanted to be able to do that, we can add in brackets require ownership and set that to false. And now we can call this method from anywhere and it will just work. We do want ownership though. We don't want to be able to change someone's Steam ID remotely. That would be stupid. It also has a overload for running on the client as well. So we can actually add this code to execute on the client locally if we so wish. In this case, we don't need to do that because we're updating a sync var, and this is going to propagate to all of our clients as well. So let's go ahead, and in here we are simply going to say player Steam ID equals Steam ID. And we can also update the username as well, because the username is going to be based on whatever the Steam user is. So we can say player username equals Steam friends dot get friend persona name, and we pass in that Steam ID as a C Steam ID. Boom. Oh, who we got? Oh man, I should be wearing my glasses. Gust3Roo, welcome. Hello, nice to see you. Thanks for stopping by. We're very deep in, I say very deep, we're pretty shallow into making networked games through Steam, and we are currently in the process of setting our username on the server. Very fun indeed. So yeah, now what will happen, we need to call this now. So in onStart client, let's call this method. Let's do server set Steam ID, and we will pass in our Steam client dot get Steam ID. Wait, no, what's this one? Steam user dot get Steam ID. Yoink, copy, yoink, paste. And we want to then put Steam ID on the end here, because Steam ships it as a C Steam ID, and we want to pass it through as a ulong. So now, when the client is initialized... Oh, wait, is that one I want to do? That's not what I want to do, is it? To explain why that's not what I want to do, this method will get run on all of the clients when it's initialized on the client. So we'll actually end up setting the Steam ID... oh, wait, no, that's fine. Here we go. So we can fix this by saying if not is owner... return. There we go. So, and I mean, we should do this anyway, because if we try and call this method from an object that isn't the owner, then it's going to throw an error, as I was saying earlier, or it will give us a warning. But yeah, so what we want to do, if we're not the owner of this object, and isOwner is a boolean that's provided by Fish Networking by default, if we're not the owner, we don't want to run any of this code, because we don't want to initialize the lobby UI on our object for every player that joins. We just want to initialize for our object that we own on the client that we're running. So on start client, if we're not the owner, return. Otherwise, let's update the server with our Steam ID and initialize our lobby view. So I'll tell you what, let's put a debug.log, debug, make sure we're using Unity engine.log, use an interpolated string again, and in this one we're going to say updating server for user, and let's pass in our player username. So now when we press play and we host the game, we should be able to see a logout on the server to say that we are updating, updating server for user Cubsyman234. And we can see as well, if we look at our player network object, it's updated our player Steam ID value in here, as well as our player username. Very good, very nice. Let's do a ready up system, shall we? So, similar sort of thing. Let's make a sync var public, public bool is ready. And we'll do the same sort of thing again. Let's have a server RPC public void server set is ready. It's going to take in a boolean is ready. Quite simply, we will say is ready equals is ready. Very nice, very easy. And this obviously is going to be useful for our game manager when we want to start the game, because we want to be able to only start the game if all the players are ready. So let's get rid of this debug.log, or we'll keep it actually. We'll change it. Yeah. We'll just update it. So we'll say can start game, and this is going to be player. We're going to use link. We're going to do players dot all. That's it. Using link. So link is a very nice execution library for running commands on all, across all entries in a list. So the syntax for this is using what are they called? Lambda expressions. So we're going to say P, which is the player, the item in our list. We'll do equals and a greater than sign, which signifies the lambda expression, and then our condition is going to be p dot is ready. So what this does now, this will return true if for all players the player is ready, and it will return false if any of these players have is ready as false. Add a comma and we'll say ready player count. Ooh, careful. That was a bit close. It was a bit close. Player ready count equals players dot count. So similarly, players dot count will return the number that meet this condition. We'll do p dot is ready. So the number of people that are ready out of players dot count. And this time we're doing players dot count as in the number in the list. Count in the list. Very good, very nice. So if we hit play, host the game. Let's just clear the console so we can see here we're getting our logs out. It says can start game is false. Player ready count is 0 out of 1. Oh, I didn't want to do that. I wanted to try and make the font size larger. I wonder if I can... Ooh, that's fun. Yeah, I'm wondering if I can just like increase the size of the text in the log, but it doesn't look like I can, unfortunately. So yeah, we're getting a log out saying that can start game is false, ready player count is all of this, but we don't have any way of setting ourselves ready, so let's go ahead and add that. I want to use the new input system for this, and we're going to use the new input system through classes. So let's do two things. We're going to add in a button for readying up or toggling our ready state, and we're going to add in a button for leaving the lobby. So I think leaving the lobby we'll do by double tapping Q, and readying up we'll do by tapping R. So I'm going to do this in a kind of cheaty way. I'm going to add a player input component to the player, and then hit create actions because I'm lazy and I like having default actions there for me. I'm going to call my actions controls, and I'm going to dock this down here to the right of my console. Can remove this component from my player prefab now, And the final thing I'm going to do is go ahead and generate a C# class for my input actions. Hit apply on there, and we are in business. So, like I said, we're going to put something for readying up and something for quitting the lobby. So we'll add a new action, which I'll call ready. It's going to be a button. We'll add our binding to the R key. Very good. And then we will add leave lobby action, no spaces. This is going to be a multi-tap interaction. Tap count is 2, so you have to double tap it to trigger it. And we will set the button to Q, as I said. Save that. And actually, let's just go ahead and make sure that I've got these set as being on the keyboard and mouse. There we go. Cool. So now that that's all sorted, let's actually do this stuff. I find it funny how everyone has agreed to call it the new input system. Yeah, it's been around for like 4 years. I was saying the same thing. It's really random. It's like it's been around for so long, like you say, and everyone still calls it the new input system. Which is, yeah, it is funny. Interesting, definitely. I think at some point actually no, I don't think it'll ever change. It'll always be the new input system. So let's go ahead, and I'm going to have a private controls. So this is our C# script that we generated for the controls that we made earlier. Private controls. I want this to be static as well, actually. And we will have a public static controls, which is going to just have a get. We're not going to have a set for this. And in here we'll say if underscore controls is equal to null, return underscore controls equals new, like that. So this will return a new instance of our controls. Otherwise, we can just return our controls. Jolly good. And then on the client, we can initialize this stuff because we don't want the controls initialized on the server. It doesn't make any sense. The server's not going to be pressing the buttons. The client's going to be pressing the buttons. So on our client, let's go in here and initialize our inputs. So first of all, controls with a capital C dot enable, make sure they're running, and then we're going to say controls dot UI dot ready plus equals and we're going to use the lambda expression here as well. We'll say ctx, throw in an arrow, and we're going to do server set is ready, passing in not is ready, like so. Oh, I want this to be ready.performed, sorry. Controls.ui.ready.performed. So if we perform the ready action, we will just toggle our is ready state. Otherwise, other thing, controls.ui.leaveLobby.performed plus equals, and we're actually just going to do client manager, and we don't need to use the instance finder here because we're a network behavior and it's already accessible. Client manager dot stop connection, and it's as simple as that. That will shut down the client, and the network manager will handle all of our things. Oh, actually no, I am gonna make a method for this. I'm gonna do a public. Yeah, we'll make it public. A public void disconnect from game. And we're going to do our things in here. So let's call disconnect from game here instead. So the reason I'm doing this, I want to stop the connection, but I also want to leave the lobby. So Steam manager, Steam matchmaking.leave lobby. And we need to pass in our lobby ID. So let's grab our Steam lobby.lobby ID. And this is all being run on the client, and we can force this as well by adding the client tag here, so it just makes sure that this is a client that we're going to run this code on. But yeah, so when we disconnect from the game, we can perform this on the client side. It'll stop our connection, and we'll also leave the lobby on Steam as well, so there's no weird stuff going on. If we try to join back in and it's like, you're already connected to this lobby, we'll be like, no, we're not, but on Steam side we will be. So that'll handle that. And now we have everything we need. Basically, we can ready up, we can ready down, and we can connect and disconnect from the lobby. So first of all, let's check that that's working from the UI, from the console, sorry. And then the final thing that we'll do probably on this stream today is set things up to work in the UI. So we can display, this is the player, this is the player's name, they are connected to the server, or well, they are ready or they're not ready. And we'll also add a field for if we're the host. We'll display if we can start the game or not. So, testing out our thing that we've just done. Let's host a game. We've got our log here saying can't start game is false. Ready player count is 0. If we press R, there we go. We've got a new log saying we can start the game. We've got 1 out of 1 players are ready. We press R again. It goes back to printing out 0 out of 1 ready. Double tap Q. Oh, I double tapped Q and it hasn't disconnected us from the server. Or it hasn't switched back. Oh no. Oh no, that's not what I wanted to happen. That's interesting. Oh! Yeah. I realise why this is the case. We didn't stop the server, so the server was still running. We've just disconnected our client. So we actually want to do a check here. We want to say if is server, then we will do server manager dot stop connection. And this is kind of weird to do. Real quick before I explain why it's weird, we want else if is client. And we do want it to be an else if for if we're the client. Because we want to say basically if we're the server, we stop the server's connection. Otherwise, if we're the client, we stop the client's connection. And with a server, if there's a client connection running, we automatically stop the client connection on the server as well. And we're passing in this parameter true to send out a message to other clients to say that the connection is stopped. So we'll disconnect all the other clients too. Yeah, the reason why I was saying this is weird is because obviously we're calling this method from a client, but one of these clients is going to be the server as well. So it's kind of like you can run stuff from both sides. So when we disconnect from the game, if we are the host, we're both a client and a server, so is server is going to be true and we'll run this stuff. And then regardless of which we are, we're going to leave the lobby. Let's just make sure that's working before we move on to setting up the UI with all of that info. Host game. There we go. And double tap Q. And it's taken us back to the main menu. Very cool. If we host game again, everything still works. We can still press R to ready up. Ooh. Cannot complete action because client is not active. What? But I just started the client. And we have our player clone here. Yes, that's good. Line 47, let's take a look at the line that's calling this. Oh, I know why, and it's because I'm an idiot and not following my own rules. Tuxedo Cat Productions, welcome, my friend. Good to see you here. Network code today. I've just made a rookie mistake. Important lesson here. And I've said it multiple times in this stream already, and then not done it here. We need to unassign our events. We have to deregister, otherwise it's going to load up multiple, and that's what's causing this warning to throw, because it's trying to run that code on the client that we've just destroyed when we disconnect it. So let's go ahead and make a on destroy. I'm going to copy this, paste it in here, controls.disable, and I'm going to say minus equals that and minus equals that, because I don't think I can do dot remove like a performed dot. Yeah, no, I can't. Although in practice I remember this not working properly. It still shows the same issue. I'm going to test it again real quick. We'll see what the case is. So yeah, we can ready up and ready down as normal, disconnect from the game, press host again. Yeah, we still get our warning. So yeah, if we're using Lambda expressions in these, you can't remove them. So what I'll actually do, if we make this callback context, make sure we're using input actions, ctx, and then we can just have this run directly from there. And that means we can actually assign and unassign the method properly. And we'll do the same for setting if we're ready. We'll have a private void set is... no, we'll make this public because we might want to run it from the UI at some point. Set is ready. Callback context. Context. And do the same thing here. Set is ready. And then obviously the code in here is just going to be the same. We'll call server set is ready with not is ready as the value that we pass through. Okay, so while we're here, also, there are messages coming through on chat. The chat box just isn't working on this screen for some reason. I don't know why. As previously demonstrated, if I hop over to this lovely screen, we can see we do have chat messages in the box. So, OBS is just stupid. I don't get it. I don't get why it works or why it doesn't work. Yeah, we'll figure it out at some point. We'll get it working. I also think I am going to have to bring down the font size a little bit because I want to fit more messages in here. So let's test this out. What I was going to say, yeah, while we're here, this is like a good point to go over any questions. If anyone's got any questions to ask. There we go. Our warning is gone now. We've just got the send broadcast issue because server's not active, which is a standard thing. But we can press R, we can quit the game, we can join back in, we can press R, and that all works. Does anybody have any questions about any of the code that we've done so far before I move on to setting it up so we can display all of this information on the lobby UI? I'm going to give it a decent pause because there's a fair bit of latency on the stream. I want to make sure I don't miss anything. But we'll give it like an extra couple of minutes. It's always like, it's nice to have a pause just in case, you know, it takes some time sometimes, YouTube pulling stuff over. But by the looks of things, everyone seems to be happy enough. Nothing showing up yet. So I'm going to assume we're good to continue. Let's crack right on. So we want to be able to display in our lobby. Let's head over to our lobby scene. I want to show maybe we want to show, oh, no, we don't need to show who's in the lobby because we're going to have physical characters walking around the lobby. I forgot about that. But I want to be able to show the name of the lobby, which we did. I want to show how many players are in the lobby, how many players in the lobby have readied up, and also if we're readied up or not. So let's just tweak our UI a little bit. I'm going to take all of this stuff and pop it up into the left. Why is my lobby view a weird aspect ratio? What is going on? Oh no, it's not. It's because these are center aligned. Let's left align them. That's better. Are they the same height? Let's make them the same height. Let's make them like not 750, 75 units tall. We will have the lobby name in bold because you know I like kind of messing around with things. Set position Y. Let's have like padding of 25, so you're going to be negative 75 and why is my anchor in a weird position? 450, 425. There we go. This is going to be players ready count. Players ready is going to be question mark out of question mark. Let's put some spaces in there. Move this one down a bit. Duplicate this again. This is going to be ready state, which is going to say ready or not ready, depending on if we are ready or not ready. Let's actually set these positions properly as well. So you're going to be, well, 75 times 2, 150, negative 150. You're going to be negative 225. Yep. And then finally, I'm going to have one more for can start, which will simply have, say, press I don't know, maybe P. I don't know why P, to start the game. And we'll put this in bold as well. You are going to be negative 300. And that is all the information we need. Question, I'm curious as to why you changed the color of the Shiba. We've been experimenting with a load of different stuff for the branding. I felt with the, you know, this is more kind of business side of stuff, with the way that the website was looking and everything that was going on. We did actually have a dark Shiba finish or UI style originally. There was the normal colored Shiba and then the colored one. But with the rebrand and the change of color schemes and everything, it kind of, we went down the line of, we wanted to redesign the logo slightly for the Shiba Dog Games section of the studio. Because actually, I don't know if I explained this in my video, but basically I've split Shiba Dog Studios into 3 sections. There's Shiba Dog Games, which is me, Jaden, and Matt. We are the internal development team, as it were. We make our games and release them under Shiba Dog Games and under the Shiba Collective. The Shiba Collective is effectively like I was explaining in the video. It's like an Xbox Live. Oh, my camera is about to die. That's fine. if video goes, it's like a sort of Xbox Live Humble Bundle type situation where games can release under there and be available for a monthly subscription. For the time being, that will just be games that we make, but in future I want it to be other people's games as well. I want to be able to support other smaller developers like yourself in making games, and that will be in the form of, here's a lump sum of money, can we put your thing up on this subscription? And that's the Shiba Collective, effectively. And then there's a third part, Shiba Media, which is all of the non-game development stuff I do. So things like music production, things like graphic design might come along in that eventually if I can bring some people who understand design on to do work under the company. Marketing, or specifically digital marketing, and like video production services, which also the new camera ties into that. And just all that stuff. So the new Shiba logo that I've got on screen at the moment is the Shiba Dog Games logo. Shiba Dog Studios has the blacked out silhouette Shiba that you can see on the website. And yeah, the old logo might still come up in some places. I might use it for the Shiba Media logo. We'll see. So, we've got about 20 minutes left of the stream. I think in this last 20 minutes, we can make all of this stuff work. So, the way this lobby is going to work, if we are the host, we will show and hide this press P to start the game text when everybody is ready. You know what? No, let's do it different. So I'm actually going to move the ready state up. You are going to be -150 and you are going to be -225. Yeah, my camera's just died, so I've lost video stream for me, but that's fine. So the way that we're going to work this is if we're not the host, we're going to hide the players ready and the press P stuff. And only show the name of the lobby and if we're ready or not. Otherwise, if we are the host, we'll show how many players are ready and to press P to start the game. Axel's heading out. Thanks for stopping by and for watching for so long, dude. I really do appreciate it. I hope you enjoy the rest of your day, and hopefully I'll see you in the next one on Tuesday. Tuxedo Cat Productions, honestly really cool what you've been changing. I'm starting second year. Yeah, of course, game design at uni. So doing stuff like 3D animation. Oh, cool. That's very cool. And yeah, if once everything's up and running with the Shiba Collective stuff, I mean, it's still going to be, there'll be criteria. It won't just be a case of like anyone who comes to us, I'll say, yeah, we'll give you some funding and host the game. It'll be games that creatively speaking fit the narrative of the company, and from a visual perspective can fit as well. Those are also things that we can offer help with, are things like the programming and the visual side of stuff. So definitely I'll be posting loads about it in the Discord server, which I know you're a part of. Anyone else who wants to find out more about that, there's a link in the description. But as it comes up, I'll be posting lots more info about it in the Discord server, and yeah, just keep following. I'll make sure to keep you posted on it. So, let us go ahead and do this setup. So first things first, let's update our lobby view. Rather than lobby member count, we'll rename this to lobby member ready count. And we can actually just nab this this text out of here, which is really handy. Change this to players ready and paste this in here. Yeah, this needs to be game manager.instance.players.ready, and same thing here, game manager.players, no, .instance.players, even instance.players. Whoop. Scroll and game manager dot dot instance dot players. Make sure we import link because we want to be using that, and let's move this down a couple of layers actually as well, so we've not got like loads of lines of code going on here. Yeah, that'll do for now. It's all on one screen. Very excited to see what will happen with the company. Thank you, dude. I do appreciate it. I'm feeling really good about everything that's happening internally at the moment. I'm really excited to have Jaden and Matt working with me. I'm really grateful as well that they're happy to tag along on this while we're still working out, you know, how we can make it sustainable for ourselves, and you know, just being able to put all the stuff in place where I can be helping people like yourself out and scaling things up. Yeah, I'm really excited for all of it. Cool. So we want to display if we're ready or not, and we want to display we want to enable or disable these things if we're the host. So let's go ahead and sort that out. First of all, serialized field, private, text mesh pro, UGUI, lobby, member, wait, what do I want this to be? Is ready status. Serialized field, private, text mesh pro, UGUI, and this is going to be start game instructions. And what I'm actually going to do, I'm going to split out two different methods. We're going to have public void update client only UI. Won't be public, it will be private. And we'll also have a private void update host UI. So what we're going to do in here, updating the host UI, we will set our ready member count text because this is going to be host only. We'll also say start game instructions dot enabled or set game object dot set active, and we'll pass in game manager dot instance dot players dot all. Wait a second, I can get rid of this bit. There we go. Players.all p dot is ready. No, not his client is ready. And then we'll also call update client only UI because if we're the host, we want to update. We want to have all the UI basically. And now this is where we need to do some extra stuff. So this is literally just going to be to set the value of our lobby or our ready status. Ready status.text equals. So what do we put here? We want to figure out, first of all, which player is our local player, which player do we have ownership of, and then we want to get the value for is ready from that player. So this is actually something really easy. We could do this really easily. If we go on our player network object and we actually add a public static player network object called instance. We'll make this get private set, and then this, when we start the client, we'll say if we're the owner, instance equals this. And this is really cool because when you have a static object, obviously, or a static property, it has the same value regardless of where you call it from. You can just call it and it's there. You don't need an instance for it. And so that might make you think, but won't we just have the same player for all of our clients? And the answer is no, because the object is it's specific to different clients. The local player instance, or the player that is the owner on one client, is going to be different to another client. So when we set instance equal to this, we're actually on that specific client machine, we're saying instance is equal to the player that we own, because we're doing a check here to say if we're not the owner, we're not going to run any of this code. So with all of that being the case, we can now just go back into our lobby view and say ready status is equal to player.instance, please. Sorry, player network object dot instance dot is ready. And we'll do a question mark inline if statement binary operator. And if it's true, then we can say the text equals ready. If it's false, we'll say not ready. And that's all very cool. So the last thing that I want to do finally is determine which method we call here. So instead of running our text up here, we're simply going to do a check to say delete if network player object player network object dot is host, dot instance dot is host. We update the host UI. Otherwise, we update client only UI. The only thing I worry about is potentially this not working because sometimes it doesn't actually detect is host. So actually no, let's use is server instead. So if we're the server, we'll update the host UI. If we're the client, we'll update the client. And then same thing up here. We want to say if not player network object dot instance dot is server. So if we're not the server, we want to disable the lobby member ready count. Game object set active. And you know what? We can actually do this easier. We'll just pass in if we're the server or not. And that way everything should update properly. What kind of multiplayer game is this? It is a like a wave-based survival game, tower defense style thing, but with a crafting system driven interaction. So rather than kind of like Sanctum, actually, if I think about it, like a top-down Sanctum based on an island. So if you imagine Bloons Tower Defense, but instead of being like a god figure, you're one of the monkeys in there, and you run around chopping down trees to get wood so that you can build weapons and protective things to protect your home base. Is effectively the way that it's the way that I'm picturing it. So let's go ahead and assign all of our variables here. Hit save. Head back into our main menu and press play and see if everything works. Ooh. There we go, that's interesting. So, oh, no, that is exactly what I wanted. Yeah, so we can see we are the server. We've got our current ready status. Number of players ready is 0 out of 1. We press R. All of the players are now ready, so we can press P to start the game, but that doesn't actually do anything because we haven't set anything up yet, but that's that. And we can still double tap Q to leave the lobby. We can host a game again, and there we go. It's all updated. All still works. Great. So that's been 2 hours, or well, like an hour and a half really, because I rambled for an hour at the start. But that is the basics of how to create a lobby, an online networked lobby with Steam using fish networking. The stream is obviously going to be available for people to watch after the fact, so don't worry about that. Before I close everything off in like 5 minutes or so, does anybody have any questions about any of the stuff that I've covered code-wise in this video? In the next one, we'll be looking at actually setting up our player character and getting things moving around and maybe setting up some basic game loop. So yeah, any questions about how we've created any of this lobby code, how we've set up any of the game, anything to do with Steam? I'll leave it open for a minute. Cool. It doesn't look like we have any questions coming in. So, with all that, thank you very much everybody who's come along to this stream. I've seen a good few numbers in. Next time I will try and figure out why the chat doesn't display on this specific screen. Like I say, on the waiting screen, look at this. We've got chat coming through. I actually want to go on here and take a look at the screen size and fiddle with things. Obviously my camera isn't showing. My camera ran out of battery. Next time as well I will also hopefully have a mains battery plug for my camera so that I don't have to run with that battery. But let's go ahead on the chat box and just drop down the font size again a wee bit. I might also change the visual style to clean because it just looks a bit nicer. There we go. But yeah, cool. So yeah, I mean, not being a programmer, I would not recommend diving into the network code as a first base. And oh yeah, I'm the most professional. I don't know what you mean. But anyway, yeah, thank you very much everyone for coming and stopping by on this video. We'll figure out the teething issues next time we get on, and we'll also be setting up the the player lobby and getting a bit of a game loop going in that stream as well. So if you haven't already, please consider subscribing. If you enjoyed the stream, please leave a like and check out the other content on the channel. I will be back on Tuesday, and until then, have a good day.